Have you ever stopped to think about how the internet really organizes itself? I'm not talking about Google. I mean the other parts. The huge, hidden archives, these shadow libraries that are trying to save every single book ever written. I mean, how would you even start to catalog something that massive? Especially when it's, well, not exactly legal. It turns out, the whole thing starts with a really weird-looking file name.
And this, right here, is the mystery that kicks it all off. You see this question all the time. Someone on Reddit is asking, hey, why do my downloaded books have these bizarre, cryptic names? And the thing is, that's not a bug. It's not a glitch. That long string of characters, that's the key to the entire system.
So, that weird name, it might look like just a random jumble of letters and numbers, but it's actually the complete opposite of random. It's a perfect, totally unique identifier.
What you're looking at is basically a digital fingerprint for that file, and it has a name. It's called an MD5 hash.
Now, this whole digital fingerprint idea is the secret sauce that makes these gigantic libraries even possible. The whole system is built on this really clever trick that comes straight from the world of cryptography.
Okay, so a cryptographic hash function is basically a magic box. You can throw any file into it, a book, a picture, a piece of software, whatever, and it crunches it all down into a short, fixed-length string of characters. The specific one they use, MD5, always spits out a 128-bit value, which, you guessed it, looks exactly like that weird file name we saw.
The process itself is super simple. You take an input, say your book file, you run it through the MD5 algorithm, and what comes out the other side is a unique hash. Now here's the crucial part. If you change even one tiny thing in that file, like you fix a single typo, you get a completely different hash. It's what makes it the perfect tool for proving a file is exactly what you think it is, bit for bit.
And this is where that nerdy technical detail just explodes into this massive global phenomenon. Because that digital fingerprint isn't just for checking if a file is corrupted. It's the literal foundation for a whole new kind of library.
So what is a shadow library? Well, it's basically a gigantic online collection of books and articles and all sorts of media that completely bypasses paywalls. You can think of them as these kind of guerrilla archives for the digital age.
And those MD5 hashes, they are the catalog numbers. Forget the Dewey Decimal System. In these libraries, the file's own digital fingerprint is its unique address on the shelf. It's how they manage millions and millions of files without everything descending into total chaos and duplication.
And the scale we're talking about, it's just staggering. Just look at this number. As of mid-2025, Anna's Archive, which is kind of a search engine for all these other libraries, claims to have access to nearly 53 million books. And that entire colossal system is organized by those little digital fingerprints.
Now, this didn't just appear out of nowhere. The idea actually has its roots in the old Soviet samizdat culture, where people would secretly copy and share banned books. That spirit of free access just moved online, first to early networks, and then, in 2008, a group of Russian scientists started Library Genesis. When other libraries got shut down, LibGen would just absorb their collections, getting bigger and bigger. And more recently, Anna's Archive popped up to make all of these collections searchable in one place. So, as you can probably imagine, building a universal library of pretty much every copyrighted book ever was going to start a fight. And it has. It sparked this huge, ongoing war over who controls information itself.
For a lot of the people involved, this quote from Aaron Swartz's famous manifesto really captures their motivation. For them, this isn't about piracy. They believe that access to knowledge is a fundamental right, and that sharing it is a moral duty. It's an ideological battle just as much as is a technical one.
And the opposition? Oh, it's formidable. We're talking massive lawsuits from huge publishers. The US government has literally put them on a notorious markets list for piracy. Courts all over Europe have ordered ISPs to block them. The FBI has seized domains and even arrested people. This is a very, very high-stakes cat-and-mouse game.
But here's the real twist. That clever cryptographic tool at the very heart of this whole operation, the MD5 hash, it has a secret. It's broken. See, for a digital fingerprint system to work, it has to have something called collision resistance. It's a fancy term, but it just means it should be practically impossible for two different files to end up with the exact same fingerprint. I mean, you can't have two different people with the same fingerprint, right? Same idea.
Well, back in 2004, a team of researchers, led by the brilliant Shai-Yon Wang, did what everyone thought was impossible. They found a way to create two totally different files that produce the exact same MD5 hash. They didn't just find a crack, they blew a hole right through the algorithm's core promise of being unique.
And this is what it looks like. You have two blocks of data that are clearly different. You can see the highlighted bits aren't the same. But when you run them through the MD5 algorithm, it swears they're identical. It gives them both the exact same hash. The fingerprint is no longer one of a kind. In the world of cryptography, this was a bombshell.
So, if the very foundation of this whole library system is broken, what on earth does that mean for its future? Well, the answer reveals this really strange paradox between the technical threats and the real-world threats.
You really have to look at two totally different kinds of risk here. On one hand, you have the technical risk. What are the chances that two different books accidentally have the same MD5 hash? It's astronomically low, almost zero. The flaw exists, but it doesn't really happen by chance in the wild. But then you have the legal risk, and that risk is massive, it's constant, it's real. The true threat to these libraries isn't some obscure cryptographic flaw, it's the law.
And that's the incredible paradox at the center of this whole story. We have this project with the absolutely grand ambition of creating a permanent universal library of all human knowledge, and it's being built on a cataloging system that is known to be broken inside a legal system that is actively trying to tear it down.
So it all leaves us with one final, really important question. As our entire cultural heritage becomes digital and is increasingly locked behind corporate paywalls, who gets to decide what is saved and who has the right to access it? Is it the official librarians of the old world or the digital pirates of the new one?